So today we learned about the multiplication properties of exponents. So we're going to learn how to multiply monomials using the power rules. One thing that we need to understand before we move on is that a monomial means you have one term, whether it's 5, 5x squared, 5x squared y. These are all considered monomials. Where we get a difference is if we have 5 plus x or 5x plus x squared. These are called binomials because they have two terms, but where they are just one term, that's considered a monomial. Alright, we are given this x to the 7th. There's some things that we need to know. This first thing is that 7 is known as an exponent or a power. You can use those words interchangeably. The x is known as the base. From there, I'm going to give you 3 different properties today. The first one's called a product of a power. This says that if you multiply two bases that are exactly the same, then you will add the exponents, and the base does not change at all. So the bases have to be the same to be able to add the exponents. If the bases are different, you cannot do anything with those exponents except expand them. So in this example, we have 4 to the 6 times 4 to the 7th. The bases are the same, so it stays 4. And then we add those exponents, 13. So this is the same as saying we have 4 6 times 4 7 times. Which should give us a total of 13 fours. Okay, so on example 1, we're going to apply this rule. Here the bases are the same, so we get 2. We add those exponents. 3 plus 5 is 8. On B, we're going to make the monomials a little bit more complicated. So when you're going to do this, remember that this is still just multiplying, so that's what we will do with those coefficients. 3 times a negative 4 gives us negative 12. And then we add the exponents of the x's to get 11. On C, same idea. We're going to multiply those coefficients, 48, and add the exponents. Your second rule for today is power of a power. And I do have a typo. Let's see if I can type right over that. Or right over. No, I don't have a typo on this one. This says that if you have a power to a power, then we multiply them. And I like to use a word. I say if they're stacked, then you will multiply. That seems to help kids remember how to do that. So if they're stacked, you're going to multiply those exponents. So here we have let me change my color. We have exponents that are stacked, so we're going to multiply those, and it's 5 to the 12th. And this is 5 times 5, 12 different times. And I always tell students that if it's greater than 10,000, then we can leave it written as a base to an exponent. So we're going to go ahead and leave that as 5 to the 12th. Same idea here, we just have a variable. So we have x to the 2 to the 5th. We're going to multiply those to get 10. It doesn't matter how many we stack, the property still applies that we'll multiply those, so that's 5 to the 2 times 2 times 2 is 8, and again that's 5 times 5, 8 times, and we're going to go ahead and leave that as 5 to the 8th. Here's where I have the typo. This is your next property. It's power of a product, so if we have two different bases that we're multiplying to a power, we're going to go ahead and distribute that power to both. So it should read a to the m times b to the m, and that should be an m there. Remember that the m needs to distribute to all parts. And so we're going to go ahead and distribute this first one. This 2 has to distribute to both pieces, and remember that it is a power, so it's 5 to the 2nd and x to the 2nd. So 5 squared is 25, x squared, and that's as simplified as we can make that expression. You're going to do the 2, same idea here, so we get 6 squared, but since we have a power to a power, they're stacked, you're going to multiply those, so 3 to the 2nd becomes 6. So 6 squared is 36, x to the 6th, and again that's as simplified as that can be. Here we're going to simplify the expression, so we're just making these a little bit more complicated. You're going to take this 3 to all 3 terms, so it's 2 to the 3rd, a to the, because those are stacked, we multiply, so to the 15th, b to the 3rd, and then the only thing we can do is replace that 2 to the 3rd with an 8. And that's finished. On this one, there's a couple ways to do this, but I like to show kids that if you can recognize that you've got more than one stacking, let's go ahead and simplify that first. So 2 to the 3rd becomes 6, and then from there we'll go ahead and distribute this power to both. 3 to the 6th, x to the 24th. Sorry, I lost that screen for a second. So 3 to the 6th, then we can rewrite as 729, x to the 24th. Again, if this number is bigger than 10,000, you can leave it in exponent form. Here, again, if you notice that those are stacked, I'm going to go ahead and multiply those first. So it becomes 6, and then distribute the power to everything. So we have 2 to the 6th, x to the 2 times 6, which is 12, y to the 5 times 6 is 30, and then we simplify the 2 to the 6th to be 64, and then that one's simplified. Our last one, we're going to go ahead and start by distributing this 3 to all parts. I'm going to put this -3 in parentheses. A to the 3rd, b to the 6th. We'll do the same over on this with the 4. So you have 2 to the 4th, a to the 8th. Remember, we're going to multiply those exponents, and b to the 12th. From here, -3 cubed is -27. A to the 3rd, b to the 6th. Times 2 to the 4th is 16, a to the 8th, and b to the 12th. And then to finish this, because this is multiplying, we're going to take those two values and multiply. We get -432, and then these bases are alike, so we add their exponents. And the b's are alike, so we add their exponents, and then that is as simplified as that can be. I did go over this in class. Whoops, not that. I had a -3 to the 3rd, and we talked about this power. If this power is odd, then the sign will stay. If it's even, it will become positive. It's actually an 81. So this one stays -27. So if you can remember that, even powers give positive answers. Odd hours give whatever that sign is in front. Hopefully that will help you. Your assignment is 6-1 multiplication properties of exponents. Good luck.